The diagram shows the point A 1, 2 and B 4, 4 on the curve y equals to 2 square root of x. The line BC is the normal to the tangent to the curve FB, and C lies on the x-axis. So this is C, the coordinates will be x, 0. This is E and this is D. Lines AD and BE are perpendicular to the x-axis. It's perpendicular. Find the equation of the normal BC and find the area of the shaded region. So we know that the first derivative of a curve equation is the gradient of the tangent. To find the normal, we have to know the gradient of the tangent because normal is perpendicular to the tangent. So we have to find the first derivative, y equals to 2 square root of x. So dy dx is equals to, this is equals to 2x to the power of half. So the derivative is x to the power of negative half. And then at x equals to 4, the dy dx is equals to 4 to the power of negative 2. So it's equals to 1 over 2. This is the gradient of the tangent. So that means the gradient of the normal will be the perpendicular gradient. So it will be negative 2. So y equals to mx plus c. And then we can just put it negative 2x plus c. And since the BC passes into B, so we can use the coordinate B. So 4 equals to negative 2 times 4 plus c. So 4 equals to negative 8 plus c. So c equals to 12. So that means y equals to minus 2x plus 12. This is the first answer. Next, the second question. Find the area of the shaded region. The area of the shaded region in here is between the curve and the x-axis. So it will be equals to integral between D to E. So D in here is the coordinate of A, 1, and A is the coordinate of B, 4. So this is 1 under 4 of y dx. So this is equals to integral 1 under 4 to x to the power of half dx. So equals to, this is x to the power of 3 over 2, and this will be 4 over 3. And then we put the boundaries here. So 4 over 3, 4, 3 over 2, minus 1, 3 over 2. So this is equals to 4 over 3, 8 minus 1, so it's 28 over 3. That's it for number 1. Number 2. The diagram shows the curve where k is a constant. The curve has a minimum point on the y-axis. Find the value of k. So again, we know that the function has a minimum point. So we have to find the stationary point. As we know that the stationary point is when the first derivative equals to 0. So first we have to find the derivative of the function. The function is x cubed minus 3x squared minus 9x plus k, so it will be 3x squared minus 6x minus 9 equals to 0. And then I can simplify this. Minus 3 equals to 0. So x minus 3 and x plus 1. So x equals to 3 or x equals to negative 1. So from here, I can see that this is x equals to negative 1, and this is x equals to 3. So to find the value of k, I can just put the coordinate of the minimum. This is 3, 0, because it's lying on the x-axis. So I can put it 3, y equals to x cubed minus 3x squared minus 9x plus k. I replace the 3, 0. 0 equals to 3 cubed minus 3 times 3 squared minus 9 times 3 plus k. So k in here is equals to 27. So the full equation will be y equals to x cubed minus 3x squared minus 9x plus 27. And we can find the coordinate of the maximum point for the answer question 2. So we just replace the coordinates of this when x equals to negative 1. So it's negative 1 cubed minus 3 negative 1 squared minus 9 negative 1 plus 27. So this is equals to negative 1 minus 3 negative 4 negative 1 plus 9 5, so it's 32. So the coordinate will be negative 1, 32. And then the third one, state the set of values for x for which decreasing. So we know that from the graph will be decreasing in this region. So that means the function will be decreased between negative 1 and 3. We know that it is decreasing because of the gradient is negative. So from the graph, we see that the gradient negative between negative 1 until 3, between that region. And then the fourth one, find the area of the shaded region. So this is integral of y dx, because this is the area between the curve and x-axis. And for the boundaries, it's from 0 until 3. So integral 0, 3 x cubed minus 3x squared minus 9x plus 27 dx. So 1 over 4 x cubed x4 minus x cubed minus 9 over 2x plus 27 squared plus 27x, and then put 0 and 3. And then we put it into the calculator. So it's 3 squared, 1 over 4 times 3, 4, times 3 to the power 4, minus 3 cubed, minus 9 over 2, 3 squared, and that plus 27 times 3. So this is equals to 135 over 4. Minus 0, so it will be 135 over 4. Number 3. The diagram shows the curve y equals to 6x minus x squared, and the line y equals to 5. Find the area of the shaded region. So from here we can see that The area is between the curve and the y equals to 5. So we can find the area using the integral of the function 6x minus x squared dx minus with the area of the rectangle. The problem is we don't know the boundaries. The boundaries are the intersection points. So we have to find the intersection point first. So we make the function the same. So it's 6x minus x squared equals to 5. So x squared minus 6x plus 5 equals to 0. So x minus 5, x minus 1. So x equals to 5 and x equals to 1. So this is 1 and this is 5. So the boundaries will be from 1 until 5. So integral 1, 5, 6x minus x squared dx minus the area of this rectangle. So this is 5 and this is 4. So 4 times 5. So we integrate this. This becomes 3x squared minus 1 over 3x cubed, 1 until 5, minus 20. So 3, 5 squared minus 1 squared, minus 1 over 3, 5 cubed minus 1 cubed, minus 20. Equals to 3 times 24 minus 1 over 3, 124, minus 20. So we have 3 times 24 minus 1/3 times 124 minus 20. So equals to 32 over 3. Number 4, the diagram shows the curve and the line which intersect at point A and B. When the area of the shaded region, the same, we have to find the intersection points. So from this, y equals to 7 minus 2x. And I can make it the same, x minus 2 squared equals to 7 minus 2x. Yeah, y equals to y. So I can expand this, x squared minus 4x plus 4 equals to 7 minus 2x. So x squared minus 2x minus 3 equals to 0. So x minus 3, x plus 1 equals to 0. So x equals to 3, x equals to negative 1. So this is negative 1, and this is 3. And for the area, is integral from negative 1 until 3 of the line 7 minus 2x minus with the curve x minus 2 squared dx. We put the bracket here. So I can just integrate it. 7x minus x squared minus x minus 2 to the power of 3, 1 over 3. Negative 1, 3. And this is equals to 7 times 3 minus 1 minus 3 square minus negative 1 square minus 1 over 3, 1 cube minus negative 3 cube. So this is 7 times 4 minus 8 minus 1 over 3 times 28. So equals to 7 times 4 minus 8 minus 28 over 3 equals to 32 over 3. Number 5, curve has equation, write down the expression for first derivative and second derivative. So the first derivative, y equals to x squared plus 2 over x. So dy dx equals to dou x minus 2x to the power of negative 2. Yeah, we can change this into 2x minus 1. So this is the expression for dy dx. And for the second derivative equals to, we derive this, so 2 plus 4x minus 3. That's for number I. Find the coordinate of the stationary point of the curve and determine its nature. So the stationary point is taken from dy dx equals to 0. So 2x minus 2x minus 2, I can rewrite as 2 over x squared equals to 0. So I can just make the denominator the same. So it's 2x cubed minus 2 equals to 0. And that means 2x cubed minus 2 will be equals to 0. So 2x cubed minus 1 equals to 0. So x equals to 1. And y is equals to, we just put into the formula. So 1 squared plus 2 over 1 equals to 3. So the coordinates of the stationary point is 1, 3. And the nature, using the second derivative, 4 over x plus 3, since the x is positive. So the second derivative will be equals to 2 plus 4 over 1. So it's 6. So greater than 0, that means this is a minimum value or minimum point. And for the third one, find the volume of the solid form when the region enclosed by the curve, the x-axis, and the line 1 until 2 rotated completely about the x-axis. So that means we have to find the integral between 1 until 2 pi y squared dx. So we can just put pi integral 1 until 2, the function x squared plus 2 over x, so square dx. And then this is pi integral 1 until 2, so x4 plus 4x plus 4 over x squared dx. And then this is pi 1 over 5 x5 plus 2x squared plus, okay, this is 4x minus 2 is negative 4x minus 1, 1 until 2. So this is pi 1 over 5, 2, 5 minus 1, 5 plus 2 2 square minus 1 square minus 4 x to the power of 1 negative 1 is 1 over 2 minus 1 over 1. So this is pi 1 over 5 times 31 minus 2 times 4 minus 1 is 3 and minus 4 times negative half. So this is equals to 31 over 5 minus 6 plus 2 equals to 11 over 5 pi. So this is the volume. Number 6, the similar question. So y equals to 2x plus 8x squared. Find the expression for the derivatives. So y equals to 2x plus 8x minus 2. So dy dx will be 2 minus 16x minus 3. And the second derivative equals to 48x minus 4. I find the coordinates of the stationary point on the curve and determine the nature of the stationary point. So stationary point is when dy dx equals to 0. So 2 minus 16 over x cubed equals to 0. So I can write as 16 over x to the power of 3 equals to 2. I can cancel this, so 8. So x cubed equals to 8, so x equals to 2. Coordinates, so we have to find y. Y, we can just put it into the original function. So 2 times 2 plus 8 over 2 squared equals to 4 plus 2 equals to 6. So the coordinate will be 2, 6. And for the nature, we can put it into the second derivative. When x equals to 2, the second derivative is equals to 48 over x4, so over 2 to the power of 4, so equals to 3, greater than 0. So that means this will be a minimum value. Triple I. Show that the normal to the curve at the point -2, -2 intersect the x-axis at the point -10, 0. So to find the normal, we have to find the gradient of the tangent. So the gradient of the tangent is taken from the first derivative of the equation. So dy dx. So dy dx equals to 2 minus 16 over x cubed. And then put the x is -2. So dy dx will be equals to 2 minus 16 over -2 cubed equals to 4. So this is the gradient of the tangent. So the gradient of the normal is -1 over 4. And the equation is y equals to mx plus c. So -1 over 4x plus c. And then since the normal pass through the -2, -2, I can replace it. So it's -2 equals to -1 over 4, -2 plus c. So it's -2 equals to 1 over 2 plus c. So c equals to -5 over 2. So So the equation is y equals to negative 1 over 4x minus 5 over 2. And it will intersect the x-axis at the point. So find the x-intercept. X-intercept is when y equals to 0. So negative 1 over 4x minus 5 over 2. So 1 over 4x equals to negative 5 over 2. I can cross this, so this is 2, so x equals to negative 10. So the x-intercept will be negative 10, 0. Shown, yeah? And for the last one, find the area of the region enclosed by the curve, the x-axis, lines x equals to 1 and x equals to 2. So the area will be integral from 1 until 2 of the curve. So 2x plus 8x minus 2 dx. And then we integrate this, become x squared minus 8x minus 1, 1, 2. So it's 2 squared minus 1 squared minus 8, 1 over 2 minus 1 over 1. So this is 3 minus negative 4. So equals to 7. The diagram shows part of the curve y equals to 9 minus x cubed and y equals to 8 over x cubed and their points of intersection P and Q. The x-coordinate of P and Q are A and B respectively. Show that x equals to A and x equals to B are roots of the equation. Solve this equation and hence state the value of A and the values of B. So since A and B are the x-coordinate of the intersection point, so we have to equalize these both equations. So I can rewrite as y equals to y, 9 minus x cubed equals to 8 over x cubed. And then I cross multiply, I multiply by x cubed. So it's 9x cubed minus x6 equals to 8. And then I simplify into x6 minus 9x cubed plus 8 equals to 0. So this is the equation of the combined function. If we solve this equation, we will have the roots of the intersection point. So that means A and B will be the roots of this equation. Now we have to solve the equation. We can simplify this as the quadratic equation. I can say this A as the x cubed. So that means I can have a squared minus 9a plus 8 equals to 0. So this factorized will be a minus 8 minus 1. So a equals to 8 or a equals to 1. So x cubed equals to 8. So x equals to 2. X cubed equals to 1. X equals to 1. So that means a is 1 and b is 2. A here is not related to the a in here, yeah? It's not related. That's all for I. For II. Find the area of the shaded region between the two curves. So for II, area between the two curves, so this will be integral. This one is on the top, so 9 minus x cubed will be minus with the lower function 8 over x cubed dx from 1 until 2. So we can integrate this 9x minus 1 over 4x4 plus 4x minus 2. 1, 2. So it's 9, 2 minus 1, minus 1 over 4, 2, 4 minus 1, plus 4, 1 over 2 square, minus 1 over 1 square. So this is equals to 9 minus 1 over 4 times 15 plus 4 times 1 over 4 minus 1. So it's 1 over 4 minus 1. So this is equals to 9 over 4. And then the tangent to the curves at x equals to c are parallel to each other. Find the value of c. So c will be between a and b, and the tangent are parallel. So that means we have to find this. So we have to find the gradient of the tangent from both curves. So from the first one, y equals to 9 minus x cubed. So dy dx will be equals to minus 3x squared. And for the second one, y equals to 8x minus 3. So dy dx will be equals to minus 24x minus 4. And then we have to make the same because they say the gradient are parallel. So the gradient will be the same. So it's negative 3x squared will be equals to negative 24x negative 4. I can divide it. So this is 8. So x to the power of 2 equals to 8x to the power of negative 4. So that means this will be, I can rewrite this as x equals over 4, x to the power of 4. And this is x squared. So I cross multiply, x6 equals to 8. So x equals to 8 is 2 to the power of 3 times 1 over 6. So it is equals to 2 to the power of half. So square root of 2. The question, find the value of c. So that means c will be square root of 2.